Hello.
Hello.
Team HBBC04, you have two members, right?
Yes.
Okay. Welcome to the Global Youth Science and Technology Bowl 2020. Team HBBC04 is from Hong Kong. Their project title is Revolutionary Discovery of Hair. We would like to thank you for attending the online judging today and for your efforts made in the past few months. Today, we are happy to have Professor Lam Hong Wah from City University of Hong Kong, Dr. Wong Chat Loi Carmen from the University of Hong Kong, and Dr. Wong Yi Kern from Episteme Co. Limited to be the judges of the competition. You will have 5 minutes to present your project. When time is up, we will stop your presentation. After that, we will have a 4-minute Q&A session. You will be able to see a timer on my screen. Judges, are you ready?
Okay.
Team, are you ready?
Yes.
Okay, you may start your presentation now.
Our study is the revolutionary study of hair. So around the world, 35 million men and 21 million women suffer from having weak hair, which reflects a low awareness on the negative effects of commonly used hair treatments and products. So our aim of this study is to understand hair of humans, raise awareness on hair treatments, and in order to do so, we would like to simplify the self-evaluation process of hair shampoos and lotions by providing an easily understandable index for reference. Hair is made up of largely keratin, and it is a fibrous helicoidal protein which serves important structural and protective functions. Hair is made out of major 3 parts, the medulla, cortex, and cuticle. There are 3 major intermolecular bonds in hair, the disulfide bond, the hydrogen bonds, and the salt bonds. The disulfide bond is positioned between the beta-pleated sheets and holds the alpha helix together. It is essential to break this bond to change the appearance of hair, and it is also the strongest bond in hair. The hydrogen bonds are most readily broken down and reformed and account for 30% of strength and 50% of elasticity. The salt bonds are present between cysteine and melanin. However, they contribute to a small portion of overall strength and elasticity. This is an overall look at the 3 bonds working together in our hair. Our experiment consists of 2 parts. Firstly, is testing the presence of RSH using sodium plumbate solution. It gives a blue-black precipitate when hydrogen sulfide is produced, when the disulfide bond is broken. Firstly, we will measure the diameter of each strand of hair to determine its cross-sectional area. Next, we will use a stress test experiment to determine the force needed to break the hair strand. This is our stress test setup. A hair strand is placed between, is clamped, and there's a burette pouring water into a cup. And after the hair strand breaks, we measure the weight of the water inside the cup, and we use F equals ma to measure the force needed to break the hair strand. In addition, we will also measure the stress using the following formula. Finally, we will plot graphs with percentage change in stress to the corresponding independent variable. For example, here we can see a graph plotted against time.
And so let me talk about the study on the behavior of the, the hair protein on different strong treatments. So firstly is the effect of the keratin of hair on different temperatures. As shown in the graph, the maximum stress of the hair can withstand decrease with the temperature with a decrease of 28.2% in 150 degrees. And here shows 2 microscope diagram under 100 degrees Celsius and 200. And it can be seen that the melanin degraded under 150 degrees, while the hair is totally structurally deformed under the 200 degrees Celsius. And for effects on hair under high pH environment, we used the KOH as the strong alkalis and sodium carbonate at the weak base. It can be seen that the hair is totally dissolved in KOH, while the hair is still in shape under the treatment of Na2CO3. And the percentage change in stress after 5 days for KOH is 100% since the hair is totally dissolved, and in Na2CO3 the change is only 35.8%. And both shows positive results in the sodium plumbate test, showing that the RSH is released and the disulfide bond is broken down. And for effects of hair under low pH environment, in both HCl, which is strong acid, and ascorbic acid is weak, that both hairs are still in shape and salt bonds are broken down. And the percentage change in stress after 5 days is larger for the HCl than ascorbic acid. And for both results in sodium plumbate test, it shows a negative result, which shows that the disulfide bond is not broken down. To summarize, the stronger axis do more damage. The stronger axis and stronger alkalis do more harm compared to the weak ones, and the effect of alkalis is greater than that of the acid. During the experiment, a range of pH 2 to 12 is investigated, and we take the results after 2 hours in order to simulate the real-life hair treatment. And here shows a general results graph. And for pH 4 to 5, there are generally no effects. Cause effect is insignificant. And for pH 5 to 6, no negative effects is made. Instead, the peak is located at pH 5.5, which it shows that the optimum pH for hair is pH 5.5. And for pH over 8.5, a considerable negative effect is imposed, which is most harmful to the hair. And for pH under 4, a negative effect is imposed, and compared to the alkaline side, is not that significant.
Therefore, here we can see that
All right,
pH.
time's up. The following will be the Q&A session.